Picture yourself on the moon, standing beneath a vast, endless black sky, with the Earth glowing like a blue marble in the distance. The silence is profound, broken only by the faint hum of your suit and the distant echoes of activity from a new world being built. All around you, a city of interconnected domes and tunnels stretches across the gray, dusty landscape. Rovers glide silently over the powdery surface, carrying supplies and people between habitats. The air inside the domes is filled with the quiet buzz of life. Scientists, engineers, and explorers working together to shape a new home. This isn't just a dream or a scene from science fiction. NASA is actively building this future right now. Teams of engineers and scientists are designing habitats, testing new technologies, and training astronauts for the challenges of lunar living. By 2027, humanity will take its first real steps toward living on the moon, not just visiting for a few days, but staying, working, and thriving in a place once thought impossible to call home. The Artemis program is more than a mission. It's a bold vision to make humanity a permanent presence beyond Earth. It's about building the foundation for a future where people can live, work, and dream on another world. The key to making this vision a reality? Reliable, round-the-clock power, delivered by advanced nuclear energy systems. Unlike solar panels, which go dark during the moon's 2-week-long night, a compact nuclear reactor will keep the lights on, the air flowing, and the city alive. This technology will provide the steady, dependable energy needed to survive and thrive in the harsh, lunar environment. With this power, we'll run life support systems, charge rovers, fuel scientific experiments, and keep the habitats warm and safe, making the dream of a lunar city not just possible, but sustainable. We are the generation that will witness robotic builders laying the first foundations, and astronauts moving into their new lunar homes. Construction will be a blend of human ingenuity and robotic precision, working together to create something truly extraordinary. The journey ahead is filled with challenges, radiation, extreme temperatures, and the unknowns of a new world, but it's the next step in the grand adventure of human exploration. We're not just going back to the moon for a visit, we're building a future there, one sunrise at a time. Imagine watching the first rays of sunlight spill across the lunar surface, illuminating the domes and habitats of a new civilization. The first sunrise of a new era, a new civilization, is about to happen on the moon. It's a moment that will inspire generations to come. The era of lunar cities is about to begin, and with it, a new chapter in the story of humanity among the stars. Returning to the moon is a series of bold steps, not a single leap. Each mission builds on the achievements and lessons of those that came before, creating a chain of progress that stretches from the Apollo era to today's cutting-edge technology. The dream of a lunar future is no longer just a vision, it's a plan in motion, unfolding year by year. Artemis II just sent astronauts around the moon for the first time in 50 years, proving we're ready for more. This historic journey tested new spacecraft systems, navigation, and life support, while giving a new generation of explorers their first glimpse of the lunar surface up close. It's a powerful reminder of how far we've come and how much further we're about to go. Starting in 2027, NASA will launch robotic landers every month, delivering tools and tech for our future base. These missions will lay the groundwork for human explorers, sending everything from scientific instruments to habitat components and power systems. Each robotic delivery brings us closer to a sustainable presence, transforming the moon from a distant world into a place we can truly call home. Artemis III will test critical systems in orbit, paving the way for the first surface landing with Artemis IV. Astronauts will practice docking, equipment deployment, and emergency procedures, ensuring every detail is ready for the challenges of lunar exploration. These rehearsals are essential for safety and success on the surface. By late 2028, NASA will launch Space Reactor 1 Freedom, testing the nuclear tech that will power our lunar base. Reliable energy is the key to surviving the long, cold, lunar nights and supporting life and research. This reactor will be a game-changer, providing electricity for habitats, science labs, and even future industry on the moon. This mission links our moon ambitions with future Mars exploration. The technologies and teamwork we develop here will be the foundation for humanity's next giant leap, sending astronauts to the Red Planet. The moon is our proving ground, a place to learn, adapt, and prepare for the challenges of deep space. By 2030, the first elements of a permanent lunar base will be in place. Modular habitats, power stations, and research labs will begin to dot the surface, forming the backbone of a new outpost. Step by step, the moon will become a hub for science, exploration, and international cooperation. Robotic landings and Artemis missions will deliver hardware and crews, with international partners adding their expertise. Countries from around the world will contribute technology, science, and people, making the lunar base a truly global effort. Together, we'll build a future that belongs to all of humanity. This marks the start of a continuous human presence on the moon. For the first time, people will live and work on another world, conducting experiments, building infrastructure, and exploring the unknown. The lunar night will glow with the lights of human activity. Soon, crewed landings will happen every 6 months as our lunar home grows. Each new mission will bring more people, more supplies, and more possibilities, turning the moon into a bustling outpost of discovery and innovation. The countdown to a lunar city has already begun. With every mission, every landing, and every new habitat, we move closer to a future where the moon is not just a destination, but a thriving world of its own. The moon's harsh environment demands constant, reliable power. Unlike Earth, the lunar surface is exposed to extremes, intense radiation, no atmosphere, and temperatures that swing from boiling hot to freezing cold. For any human settlement to survive, let alone thrive, a dependable energy source is absolutely essential. With 2-week-long nights and wild temperature swings, solar panels just won't cut it. During the lunar night, which lasts about 14 Earth days, the surface plunges into darkness and cold, leaving solar panels useless for half the month. Batteries can only store so much, and the risk of running out of power is too great for life support and critical systems. Nuclear fission is the answer. A suitcase-sized reactor can power homes and labs for years without interruption. These reactors are compact, efficient, and can operate through the long lunar night, providing a steady flow of electricity regardless of sunlight or weather. This energy independence is what will make a lunar base truly self-sufficient, freeing astronauts from the constant worry of power shortages and enabling them to focus on exploration and discovery. Astronauts will have the power to run life support, mine water ice for drinking and rocket fuel, and explore the moon's surface with rovers and scientific instruments. Reliable energy means more ambitious missions and longer stays. NASA is already building and testing these compact, safe reactors. Engineers are designing them to withstand the moon's unique challenges, from dust storms to radiation, ensuring they can operate for years with minimal maintenance. They're modular, easy to deploy, and designed for the unique challenges of the moon. These reactors can be transported in pieces, assembled on site, and scaled up as the lunar base grows. Once running, they'll provide steady power for habitats, labs, and industry, lighting up the lunar night and supporting everything from scientific research to manufacturing. With nuclear energy, we can move from mere survival to building a thriving lunar community. Imagine bustling habitats, advanced laboratories, and even the first steps toward lunar industry, all powered by a constant, reliable energy source. It's the foundation for everything: science, industry, and daily life. Without it, dreams of a permanent human presence on the moon would remain just that: dreams. The reactor is the heart of the lunar city, pulsing with energy and possibility. Our future on the moon depends on this constant pulse of power, making the impossible possible. Before humans arrive, the moon will be a robotic construction zone. Starting in 2027, robotic landers will deliver surveyors, builders, and power systems. Autonomous rovers will grade the surface, lay foundations, and connect the first nuclear reactor. International partners, like Canada, will provide versatile robotic vehicles for construction and repairs. Robots will assemble habitats, connect modules, and shield them with lunar soil. Only when the outpost is ready and safe will astronauts move in. Robots will build the house. Humans will make it a home. The first lunar city will be a triumph of human and robotic teamwork. Building a lunar city is a global effort. NASA's Artemis program unites space agencies worldwide, combining the best ideas and technologies. Japan is building a pressurized rover for long-distance exploration. Italy is designing the first lunar habitats. Canada and Europe are providing robotics and communications. The Artemis Accords ensure this city will fly many flags, a symbol of international cooperation. The moon's first city will belong to all of humanity. Building a lunar city is a marathon, not a sprint. NASA's plan unfolds in 3 phases: robotic exploration, early human outposts, and finally, a permanent city. First, dozens of robotic missions will scout for resources and test new tech. Next, astronauts will join robots to assemble habitats and power systems, establishing a recurring human presence. The final phase brings larger habitats, labs, and industry, using local resources to build and sustain the city. Each step builds on the last, solving challenges as we go. This careful, phased approach turns the dream of a lunar city into reality. The moon will become a true home for humanity. Commercial space companies are revolutionizing lunar exploration. Reusable rockets from SpaceX and Blue Origin are slashing costs and boosting launch rates. NASA now buys rides from these providers, focusing on science and exploration. The Commercial Lunar Payload Services program contracts private companies to deliver payloads and cargo. Soon, heavy cargo landers will deliver habitats and equipment for the lunar base. This commercial ecosystem will make lunar activity sustainable and spark a new, off-world economy. More launches mean a steady supply chain between Earth and the Moon. Private industry is the rocket fuel for our lunar future. Ambitious plans need steady funding and political support. NASA's budget is set by Congress, and shifting priorities can threaten progress. Recent proposals included deep cuts, creating uncertainty for science and technology. International partnerships and commercial contracts help stabilize the program. Public excitement and global cooperation are key to keeping the dream alive. Life in a lunar city will blend science with frontier living. Residents will live in efficient habitats, protected by lunar soil, recycling air and water. Days will be filled with research, exploration, and building the city. Fresh food from hydroponic gardens will supplement meals from Earth. The view, Earth shining in the black sky, will inspire every pioneer. The moon is our training ground for Mars and beyond. The first lunar city will open a new frontier for generations to come.